Okay, we're looking at question 1 for the Integration 1 tutorial in Chapter 6. Question 1 wants us to be able to integrate expressions in two forms. The first form is when we have the derivative of some function multiplied to that function raised to some power of n. That's the first type we need to be able to differentiate. The second type we need to be able to differentiate is when we have the derivative of a function divided by that function itself. So there are some points to note here. First point I really need to note is that this n up here is not going to be 0, nor is it going to be negative 1. If you want to think about it as such, the negative 1 case is really dealt with down here. The second thing I should point out to you guys is that I can have any constant I like out the front of either of these expressions. It's not going to affect the integration too badly because I can move constants in and out of the integration sign as and when I need them. So, what are we going to look at? Well, this one is shown to us quite neatly in question 1a, and this one is also demonstrated very neatly in question 1b. So let's have a look at those two questions, shall we? Okay, let's look at question 1a. Question 1a asks us to integrate x take 1 over 3 plus 2x minus x squared with respect to x. Well, what do we do here? Well, let's firstly think about, I told you this was the first type, right? So let's think about differentiating some function f of x to the power of n plus 1, right? What would we end up with? Well, from the chain rule, we know the n plus 1 comes down, then we have f of x and reduce the power by 1 to n, and then we have to multiply by its derivative. If you look very closely here, right, what do we see at this one? Well, you actually see, if this is my function here on the bottom, what am I going to end up with? Well, let's try differentiating that. D dx of 3 plus 2x minus x squared is 2 minus 2x, which is equal to negative 2 times x take 1, right? And this x take 1 here is the same as this x take 1 up here. I can make them, I can use them the same way. So what am I going to do? I'm going to treat this as f prime of x over f of x. But to do this, I need to find some way to bring into play this negative 2. But of course, since I'm dealing with integration, alright, I can just do negative 1/2 times negative 2. And that's fine. Now I've got my negative 2 in here. And because I can move multiples in and out of the integration sign, I can put the integration sign there, which is where I want it to be. Now, this is much more like what I want, right? So the other thing I've done now is, sorry, this should have been a square root. The other thing I've done now is I've rewritten this on the top line to the power negative 1/2, and I'm still differentiating with respect to x. So now what's going to happen, now I've got it in the form I need, f prime of x times f of x. All I'm going to do is, because of the chain rule, this part here will jump out of this part here when I differentiate anyway, so I don't need to worry about it so much when I'm integrating. What does that mean? It means I'm left with the negative 1/2 is still at the front, and I've just got this mess, 3 plus 2x minus x squared, and then to what power? I have to increase the power by 1 to positive 1/2. I'm not quite finished, because when I differentiated this, positive 1/2 would have come down and come out the front, so that means I have to have something for it to cancel with, and it cancels with a 2. So the 2 goes there. So if I simplify this now, what do I end up with? I end up with the negative square root of 3 plus 2x minus x squared. But hold on, there's something that I've forgotten, and that's when we integrate, we never know exactly what we get, we only know it up to a constant term. So I have to add my constant of integration to both of these. And that is my answer for 1a. So 1a. Okay, so I told you there's a second type, and that second type is 1b. So let's look at 1b now. 1b asks us to integrate 2x minus 1 over x squared minus x plus 3 with respect to x? Well, this is the type I told you about, where we're talking about f prime of x over f of x, right? So how could we get an f of x on the bottom line? We can't, or f of x to the negative 1. We can't just differentiate f of x to the power of 0, because that would be a constant, it'll disappear. But we do have a function where when it's differentiated, its argument ends up on the bottom line, and that is our natural logarithm, right? So if I differentiate the natural logarithm of f of x, what do I end up with? I'm going to end up with 1 over f of x. That's how I differentiate the outside. And then the chain rule tells me to that I need to multiply the derivative of f of x. So in other words, I end up with f prime of x over f of x, which is going to make our life very, very easy. Especially if we look at this function here, right? If we look at it, what do we see? We see differentiate x squared take x plus 3, you actually get 2x minus 1, right? Straight away. So that means I know straight away, without doing anything, this is going to be the ln of x squared minus x plus 3, and of course, plus a constant of integration. But I'm cheating you a little bit here, I must admit. I've skipped a step, haven't explained it. Why do I have these? Why do I have these absolute value signs? Well, it's simply because I can't take the natural logarithm or any logarithm of a negative number. So I need to make sure that these that the logarithm is well defined for all values of x, and as such I need the absolute value signs. If you're particularly switched on, you may realize that this isn't actually defined properly for all values of x, it's defined for all non-zero values of x. So what happens when, all values of x for which this expression does not equal to 0. So what happens if we get a 0? Well, we don't have to worry about it, because in this case, this expression here would also be undefined. So we don't need to have our integrand defined when the original expression was also undefined at that x. In fact, it would make no sense to have a value here when x squared minus x plus 3 actually equal to 0. So that is our final answer.